Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about a problem that we got from one of our followers from Indonesia. In this problem, we have 10 to the power of log m to the power of log m minus 10 m to the power of negative log m minus 3 is equal to log of 81 in base 3 plus log of 81 in base 3 to the power of 3 plus log of 81 to the base of 3 to the power of 9 and so on so forth. Before moving forward to talk about the solution, make sure that you pause the video to think about this interesting problem. See you in a bit. To solve this problem, let's start with what we have on the right hand side. We have log of 81 in base 3, we have log of 81 in base 3 to the power of 3, we have log of 81 in base 3 to the power of 9, and so on so forth. Let's write 81 as 3 to the power of 4, and then for the first one, when we have log of 81 in base 3, we can write it as log of 3 to the power of 4 in base 3. Obviously, we can write it as 4 times log of 3 in base 3, which is 4. For the next one, when we have log of 81 in base 3 to the power of 3, first we are going to write 81 as 3 to the power of 4. Then we are going to write log of 3 to the power of 4 in base 3 to the power of 3 as log of 3 to the power of 4 in base 3 over log of 3 to the power of 3 in base 3. The final answer is going to be 4 over 3. Next, we have log of 81 in base 3 to the power of 9. We are going to use a similar approach. We are going to write it as log of 3 to the power of 4 in base 3 over log of 3 to the power of 9 in base 3. At the end, we will have 4 over 9. Now let's review what we have in the next part of the video. Basically what we have is 4 plus 4 over 3 plus 4 over 9 plus so on and so forth. Let's factor out 4 first, and then we will have 4 times 1 plus 1 over 3 plus 1 over 9 plus and so on and so forth, which is a geometric series. We can write it as 4 over 1 minus 1 over 3, which is 6. If you are not familiar with geometric series, make sure that you see the Wikipedia page that we have here. When we have a plus a times r plus a times r squared and so on and so forth, and we know that the absolute value or the magnitude of r is less than 1, the geometric series can be written as the first term over 1 minus r. Here the first term is 1, so at the end we have 1 over 1 minus r, and r is 1 over 3, so at the end we have 1 over 1 minus 1 over 3, and then we need to multiply by 4, and the final answer is 6. Now let's go back to the original problem. We had 10 to the power of log m to the power of log m. We had 10 times m to the power of minus log m. We had 3, and we found that the right hand side is just 6. We are going to write 10 to the power of log m as m. To prove it, let's assume that 10 to the power of log m is a. We take log from both sides, and then on the left hand side we have log of m times log of 10 in base 10 and for the right hand side we have log of a. Log of 10 in base 10 is going to be 1, and then we have log of m is equal to log of a. So a and m are equal. So at the end we have 10 to the power of log m is equal to m. Now we can write the whole equation as m to the power of log m minus 10m to the power of negative log m minus 3 is equal to 6. We are going to simplify it as m to the power of log m minus 10 times, instead of using m to the power of negative log m, we are going to write it as 1 over m to the power of log m. Everything else is still the same. We have m to the power of log m. We are going to write it as t. Then we have t minus 10 times 1 over t is equal to 9. If we simplify it, we will have t squared minus 9t minus 10 is equal to 0. So we can write it as t minus 10 times t plus 1 is equal to 0, and t can be 10 or negative 1. Now we have m to the power of log m is equal to 10 or negative 1. Let's start with 10. M to the power of log m is equal to 10. If we take log from both sides, we have log of m times log of m is equal to 1. So log of m can be plus minus 1, and m can be 10 or 1 over 10. For the other one, when we have m to the power of log m is equal to negative 1, we don't have any solution. This is invalid, since the result of an exponential equation cannot be negative. So at the end, we have 10 or 1 over 10 as two solutions for this problem. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different math competitions and Olympiads, please make sure that you subscribe to this channel. If you have an interesting problem, please share it with me, and we will see you in the next video. This is the SQRT channel.